Hello students, welcome back. Today in this video we'll discuss the reduction formula for integration of cos power nx into dx. Proof. Let us assume in equals integration of cos power nx into dx. Let it be equation 1. Here this equals integration of cos power n minus 1x into cos x into dx. Now to this integral I'll apply integration by parts. Applying integration by parts. Here cos power n minus 1x will be our first function and cos x will be second function. So this equals first function cos power n minus 1x into integration of second function is cos x into dx minus integration to differentiation of first function cos power n minus 1 x into integration of second function is cos x into dx. So this equals cos power n minus 1x into integration of cos x is sin x minus integration differentiation of cos power n minus 1x is n minus 1 into cos power n minus 2x into derivative of cos x is minus sin x into integration of cos x is sin x into dx. So this equals cos power n minus 1x sin x, here minus into minus, this becomes plus. I'll take this n minus 1 outside, n minus 1 into integration of cos power n minus 2x sin x into sin x is sin square x into dx. So this will remain same, cos power n minus 1x sin x plus n minus 1 into integration of cos power n minus 2x. To this sin square x, I'll write it as 1 minus cos square x using the trigonometric identity into dx. So this equals cos power n minus 1x sin x plus, now I'll multiply this cos power n minus 2x inside the bracket. So I'll get two integrals here, n minus 1 into integration of cos power n minus 2x into dx. Again here I have minus sign, plus into minus is minus n minus 1 integration of here I have cos power n minus 2x into cos square x. This becomes cos power nx into dx. So equals cos power n minus 1x sin x plus, here in equals integration of cos power nx into dx, but here I have integration of cos power n minus 2 into x. So in place of n I have n minus 2. So for this I can write n minus 2 minus n minus 1 from equation 1. This becomes in. Now I'll transfer this in to the left side. In plus n minus 1 into in equals cos power n minus 1x into sin x plus n minus 1 into in minus 2. Now here I'll take in common. In 1 plus n minus 1 equals cos power n minus 1x into sin x plus n minus 1 into in minus 2. So here plus 1 minus 1 will get cancelled. The remaining will be n into in equals cos power n minus 1x sin x plus n minus 1 into in minus 2. Now I'll divide both sides by n. So in equals cos power n minus 1x into sin x divided by n plus n minus 1 into in minus 2 by n. So here in is integration of cos power nx into dx equals cos power n minus 1x into sin x divided by n plus n minus 1 into in minus 2 divided by n. So let it be equation 2. So this is the reduction formula for integration of cos power nx into dx. Note, when n is even, so I naught equals integration of cos power 0x into dx. Anything to the power of 0 is 1. So integration of 1 into dx equals x. When n is odd, I1 equals integration of cos x into dx equals sin x. Sin x. Next, evaluate integration from 0 to pi by 2 cos power nx into dx. Let us assume in equals integration from 0 to pi by 2 cos power nx into dx. Let it be equation 1. Students, we have already derived the reduction formula for integration of cos power nx into dx. So integration of cos power nx into dx equals cos power n minus 1 x into sin x divided by n plus n minus 1 by n into in minus 2. But here we have integration is from 0 to pi by 2. Integration from 0 to pi by 2 cos power nx into dx equals here cos power n minus 1x into sin x divided by n into integration is from 0 to pi by 2 plus n minus 1 by n into in minus 2. So this becomes from equation 1 in equals, students, here cos pi by 2 is 0, upper limit, after applying the upper limit we get 0, minus sin 0 is 0. So this whole term will become 0. Now we are left with the second term, that is n minus 1 by n into in minus 2. Let it be equation 2. This is the reduction formula for in. Now we have to find out in minus 2 here. So replace n by n minus 2 in equation 2, we get in minus 2 equals n minus 2 minus 1 is n minus 3 by n minus 2 into n minus 2 minus 2 is n minus 4. Now we have to find out in minus 4 here. In minus 4 equals, so replace n by n minus 4. N minus 4 minus 1 is n minus 5 divided by n minus 4 into n minus 4 minus 2 is n minus 6. Now we have to find out in minus 6. I n minus 6. Replace n by n minus 6. We get n minus 6 minus 1 is n minus 7 divided by n minus 6 into I n minus 8. So proceeding in this way, at last we get two results, that is one is for odd number and another is for even number. So it ends at I3 when n is odd. So put n is equals to 3 in equation 2. We get I3 equals 3 minus 1 is 2 by 3 into I 3 minus 2 is I1. When this is when n is odd, and it ends at I2 when n is even number. So put n is equals to 2 in equation 2. We get 2 minus 1 is 1 by 2 into I 2 minus 2 is 2 minus 2 is I naught. This is when n is even. So let it be equation 3. Substituting 3 in 2, we get In equals n minus 1 by n into In minus 2 is n minus 3 by n minus 2. In minus 4 is n minus 5 by n minus 4. And In minus 6 is n minus 7 by n minus 6, and so on. Proceeding in this way, at last we get 2 by 3 I1 when n is odd, and for even n minus 1 by n into n minus 3 by n minus 2 into n minus 5 by n minus 4, and so on. So it ends at I2. I2 is 1 by 2 I naught when n is even. Now we have to find I1 and I naught here. So from equation 1 we have In equals integration from 0 to pi by 2 cos power nx into dx. Now put n is equals to 1 here. I1 equals integration from 0 to pi by 2 cos x into dx. Here integration of cos x is sin x. The limits are from 0 to pi by 2. Sin pi by 2 is 1. Now put n is equals to 0 in In. I naught equals integration from 0 to pi by 2 cos power 0 x into dx equals, this equals integration from 0 to pi by 2, anything to the power of 0 is 1 into dx. So integration of constant is x. The limits are from 0 to pi by 2. So after applying the limits we get pi by 2. Now substitute I1 and I naught. Let it be this equation 4. Now substitute I1 and I naught in equation 4. We get In equals n minus 1 by n into n minus 3 by n minus 2 into n minus 5 by n minus 4 into n minus 7 by n minus 6, and so on, 2 by 3 into I1 is 1 into 1 when n is odd. N minus 1 by n into n minus 3 by n minus 2 into n minus 5 by n minus 4 and so on 1 by 2 into I naught is pi by 2 when n is even. So this is the reduction formula for integration from 0 to pi by 2 cos power nx into dx. Next we'll take some examples on this. First, find integration of cos power 7x into dx. Solution. We have reduction formula for integration of cos power nx into dx. In equals cos power n minus 1 x into sin x divided by n plus n minus 1 divided by n into in minus 2. Now taking n equals to 7, I7 equals cos power 7 minus 1 is 6x into sin x divided by 7 plus 7 minus 1 is 6 by n 7 into I 7 minus 2 is 5. Let it be equation 1. Now we have to find out I5. So I5 equals, now put n is equals to 5 cos power 5 minus 1 is 4x into sin x divided by 5 plus 5 minus 1 is 4 by 5 into I 5 minus 2 is 3. Equation 2. Now we have to find out I3 here. So I3 equals, now put n is equals to 3 cos power 3 minus 1 is 2x into sin x divided by n is 3 plus 3 minus 1 is 2 by 3 into I 3 minus 2 is I1. Equation 3. Now we have to find out I1 here. So I1 equals integration of cos x into dx. So integration of cos x is sin x. Equation 4. Now using equation 4, 3 and 2 in 1 we get I7 equals cos power 6x into sin x divided by 7 plus 6 by 7 into I5. I5 is cos power 4x into sin x divided by 5 plus 4 by 5 into I3. Now substitute for I3, cos square x into sin x divided by 3 plus 2 by 3 into I1 is sin x. Now I will simplify cos power 6x into sin x divided by 7 plus 6 by 7 into cos to the power 4x into sin x by 5 plus, now I'll multiply this 4 by 5 inside the bracket. I get 4 by 5 3s are 15 cos square x into sin x plus 4 2s are 8 by 5 3s are 15 sin x. So this equals cos power 6x into sin x divided by 7 plus, I'll multiply 6 by 7 inside the bracket. I get 6 by 7 5s are 35 into cos power 4x sin x plus 6 4s are 24 by 7 into 15 is 105 into cos square x into sin x plus 6 8s are 48 by 7 into 15 is 105 sin x. In the next step, I'll take sin x common. Cos power 6x by 7 plus 6 by 35 cos power 4x plus 24 by 105 cos square x plus 48 by 105 into sin x. So this is our answer. Next, evaluate integration from 0 to pi by 2 cos to the power of 5x into dx. Here n is odd, we have to use the formula in equals n minus 1, n minus 3, n minus 5 and so on 2 by n into n minus 2, n minus 4 and so on 3 into 1. Here take n equals to 5. Then I5 equals 5 minus 1 is 4 into 5 minus 3 is 2 into 5 minus 5 is 0. We'll stop here. Divided by 5 into 5 minus 2 is 3 into, since n is odd, we have to multiply by 1. So this equals 4 2s are 8 by 15. Next, evaluate integration from 0 to pi by 2 cos to the power of 6x into dx. Solution. The reduction formula is in equals n minus 1, n minus 3, n minus 5 and so on 1 divided by n into n minus 2, n minus 4 and so on 2 into pi by 2. Here take n equals to 6. So I6 equals 6 minus 1 is 5, 6 minus 3 is 3, 6 minus 5 is 1 divided by 6 into 6 minus 2 is 4, 6 minus 2 is 4 and 6 minus 4 is 2 into pi by 2. 3 1s are, 3 2s are, this will get cancelled. 5 into pi is 5 pi by 2 4s are 8, 8 to the 16, 16 2s are 32.